Please welcome Chris Culling to the stream with their talk, Demystifying RFCs, Practical Applications for Security and the Apocalypse.
Right. How are you all doing today? I'm Chris Culling, and I'm very pleased to be here. Very honored that Circle City took the time to read my RCP and let me do this. So we're going to be talking about the very serious subject of RFCs. First, I'll talk a little bit about myself. We'll go through the RFC series. We'll see why it's important to understand RFCs. We'll have a little bit of fun with RFCs because we can have fun with RFCs. And then just in case the apocalypse does come true, there are several RFCs that can actually save your life. So a little bit about me. I'm originally from Kansas City, Missouri. There we go, Kansas City, Missouri. Got a family, the wife, 3 grown children. Also have a couple of pets, a dog, 2 cats, and a Vietnamese potbelly pig. Hold on a second. There we go. And I like to use one of my cats as a meme for a lot of different things. So I figured I'd go ahead and throw her up there. I'm retired U.S. Army. I did 22 years in military intelligence. I have a bunch of certifications. I'm trying to figure out which ones to let expire first. I do have a bunch of InfoSec interests. History of the internet, CTI, for reverse engineering. I'm continuing to learn assembly language, and I'm just starting to learn Python. And regarding assembly, I think this is probably an appropriate meme. I do have a new job. I started in April. A great company called My Point Group out in Northern Virginia. Working as a CTI analyst, contracted out to HHS. So this is a good time to be in the mix with them. I'm also a volunteer with CTI League. So if you're interested in looking into that, ctileague.com. There's about 1,800 people from all around the world that are participating for free to try to help with all the issues going on with the COVID. Before I interviewed for the last couple of jobs, I was sporting a pretty good beard. Trying to grow it back right now, but when I interviewed, I had to get rid of it. It just wasn't conducive for interviewing. But I'm trying to grow it back, and my end goal is no other one than Blenster. So when my wife watches this, I'm really not going to grow my beard out that long. My team, you may have heard of them, Kansas City Chiefs. And then the hill upon which I will die. Jeff is pronounced like Jeff, like Jeffy. But that's not it, because that's just silly. That's the hill upon which I will die. And who will join me? Because Oxford Comma for life. Here's my contacts. If anybody's interested in reaching out. And one more meme there to transition. So requests for comments, otherwise known as RFCs. There are a lot of folks that haven't heard of RFCs. If you haven't, I hope you get something out of this. And then there's also a large group of folks who have heard of them, but just because they've been in class or something that they've had to read. There's a very small group of people who absolutely love RFCs and dig into them all the time. I'm one of those. If you are, you can just raise your hand where you are, and no one will judge you at all. So why should we care about RFCs? Well, Julia Evans, otherwise known as Bork on Twitter, does a series of drawings like this for to explain different things. And she did one that covers RFCs. And she pointed out the fact that they define internet protocols, which is one of the main reasons why the RFC series exists, is to explain how the internet works and so that everybody can be on the same page. So the RFC series began in 1969. Steve Crocker, one of the founders of the internet, wrote the very first note after he got together with the other founders of the internet in what they call the network working group. He wrote a note about just kind of the minutes of the meeting. After that, another individual who was there wrote another letter discussing it. And by this time, Steve Crocker decided that it would probably be good to have a collection set up to track everything that they were doing. And so that became RFC 3, which was basically him explaining that this is what he's going to do. And this was April 1969. And what's kind of funny is that at the time, and this is the first paragraph of RFC 3, the fact that he puts the word seems to consist of for the networking working group, they were just that disorganized at the time in terms of bringing the internet online. John Postal, he took over at that point and managed the RFC series for 28 years until he passed away in 1998. Now the RFC series, you can see I just broke it out by number. There's 8,770 RFCs in existence. 8,788 is the current latest number. But this is kind of how it's broken out by decade for anyone who's interested in just the progression of the numbering. And for the majority of this presentation, I've got an optional lab if you do want to participate. If you want to go to rfc-editor.org, if you have an extra screen available, you can follow along on what we're doing within the RFC editor. So the RFC editor is the resource where you're going to find basically everything that you need to find about RFCs online. Again, the address is rfc-editor.org. You'll find on the left, you'll find information about the RFC series itself. You'll find information about writing RFCs. On the right side, you'll find information on notable events and recent RFCs that have been added to the series. You can search for RFCs. At the bottom, there are links to organizations that participate in the RFC approval process. And in the center is the main section where you're going to be searching for your RFCs. And I just want to point out something very interesting. Over on the left-hand side there, under the history tab, under the series section, there's a lot of very interesting reading in that section. Notes and letters from the folks who actually created the internet. So that's something good to look at if you have some time. RFC 4844 talks about the four sources or streams that contribute to all RFCs. There's the Internet Engineering Task Force, the Internet Research Task Force, the Internet Architecture Board, and independent submissions. So the IETF, their mission is to produce high quality, relevant technical documents that continue to allow the internet to work. The IRTF, they promote research and they focus on longer term research issues related to the internet, whereas the IETF looks at much shorter term engineering type issues. The IRTF is broken down into a number of research groups. There's currently 14 that are either currently chartered or proposed for chartering. Give you a second to take a look at some of the names. One of them that I find quite interesting, apart from the Quantum Internet Research Group, is the Thing Research Group. And when I first saw that, of course, I thought of this. So it's not really applicable, but it's where I went. There's also the IAB. They provide long-range technical direction for internet development. And then finally, you have independent submissions, whereby anybody outside of those groups can submit documentation that's relevant to the internet community for consideration to be included in the RFC series. So if we go back to the RFC editor, the main section that we're going to be looking at is right in the center of the RFC series. At the top, you've got links to the 4 main sources or streams for the creation of RFCs. As you go down, you can search the entire index either via HTML, text, or HTML. In the center section, you can search by status, which is defined by RFC 2026, which we're going to cover in just one second. You can also search by the official internet standards, and you can look at any of the changes that have ever happened to the status of an RFC. So several categories of RFCs status. You have the Internet Standards track, which specifies the RFCs that are intended to become internet standards. And then you have the non-standards track, which are basically informational. So on the Internet Standards track, you have internet drafts, proposed standards, the now defunct draft standard, and the internet standard. Internet drafts are basically anything that's submitted that the submitter hopes becomes an RFC. So that goes through a vetting process before it even gets onto the official track. Proposed standards are, as it says here, generally stable, and they might need a little bit more work out in the field to prove themselves out before they're considered to be an internet standard. But that's the first step of the Internet Standards track. The second step used to be draft standards. This used to be where it was basically an internet standard, but not yet, 99%. It did allow for vendors to utilize the standard as though it were an internet standard. This was deleted, this draft standard part of the track in 2011, and we'll cover that in just a second. But some of the current existing draft standards are your TCP congestion control. SMTP is still considered a draft standard, even though they got rid of the category almost 10 years ago. And then finally, you have your internet standard. This is the top of the line. This is what the internet is built on. This is what vendors should be citing when they're talking about their products. And you've made it when you're an internet standard. So examples of internet standards are your UDP, your internet protocol, your TCP. So a lot of the internet standards were created back at the beginning, and they've just been improved upon over time. RFC 6410 came out in October 2011, and it went from 3 maturity levels in the track down to 2. So it got rid of the draft standards, and it went from proposed standard to internet standard. The draft standards that existed in 2011 were either to be reclassified as a proposed standard, which was kind of a step down, or turned into an internet standard. This was all supposed to happen within 2 years. So by 2013, all of the draft standards in the RFC series were supposed to be gone. As you'll see in a little bit, that hasn't quite happened exactly. Then you have the non-standards track. These are going to be consisting of your best current practice, informational, experimental, historic, uncategorized, and numbers that weren't issues. So your best current practices are designed to be a way to standardize practices across the internet community. And so it's exactly as you would expect a best practice to be. Some examples of best current practices are your private internet allocations, your 10 dot, your 192 dot, and the guidelines for setting up autonomous systems. The next non-standard track is RFC is the informational, excuse me. These are just put out just for general knowledge for the internet community. And so they're not official doctrine, but they are very helpful in terms of understanding how different things work. You then have experimental, which are part of some sort of research or development effort. Historic RFCs have been superseded by more recent RFCs and have been relegated to the status of historic. And then there's a number that I'll talk about in a second of uncategorized RFCs that just don't have a category yet. They consist of the RFCs between 1 and 1128. Many of them were obsoleted by later RFCs, but we'll come back to that in a second. And then you just have a number of RFCs that haven't been issued. So here's a breakdown of all 8,770 total RFCs. The most current RFC is 8,788, which is a delta of 18 unaccounted for RFCs. I tried to find them, I couldn't, so I just had to let it go. But if you take a look, you'll notice at the very bottom, out of the 8,770 RFCs, there's only 116 in 50 years that RFCs have existed that have been deemed as internet standards. If you look at the top, the proposed standards, there's 3,618 that are just kind of hanging out there, waiting to be either deemed an internet standard or to just be dropped off the books and closed out as a standard. If you look at the uncategorized, there's 887. And then the draft standard, which should have all been gone by 2013, there's still 139 of those. So I was fortunate enough to talk to a recent past RFC editor about why the fact that there are so many proposed standards that haven't been turned into internet standards, why there's still draft standards that exist, and why there are any uncategorized. And she basically told me that it was just the fact that the folks that do this work volunteer their time to these working groups and committees, and there's enough work to do that they just haven't had time to go back in. So if a vendor tells you that something is approved by the RFC and it has a status, you might want to take a look at what category that falls in, just to kind of see if is it really an internet standard, or is it just something that's informational that they're just trying to pass off as being doctrine. And this is kind of a breakdown of the different streams or sources, the committees, and which types of RFCs that they feed into. Now, when you pull up the RFC index, and you have all 8,770 of them there, that can be kind of overwhelming looking at. So I just want to break down just how to read through the index entries. So you're going to start off with the RFC number, in this case 5,234. Following that, you're going to have the title, the authors, and the publication date. All RFCs are listed by month and year. Then you're going to have the format that the RFCs are currently online in. In this case, it's text and HTML. The newer RFCs are in a number of different formats, while the older RFCs are in the formats that they've been able to either scan them into or digitize them into. If an RFC obsoletes a previous RFC, it will tell you that, which is good because then you can follow the trail of how the RFCs have evolved over the years. If it's obsoleted by another RFC, it will also tell you that. So you're not going to see an RFC just by itself and not understand how it's related to other RFCs. If an RFC updates another RFC, you'll see that there, or if it's updated by another RFC. And then there's sub-series. There's standards, BCPs, and FYIs. And if it's part of a sub-series, you'll see which one that is. The status field will tell you what the status is. This particular one's an internet standard. It'll tell you the stream that the RFC came from and the working group that was behind it, if possible. And then it finishes off with an ISO digital object identifier. So sample RFC header, once you click on the RFC number and you pull up the RFC, you'll see the header. The header will tell you which stream it came from, what the number of it is, what category it falls under, if it has a subcategory, who the authors of the RFC were, and when the RFC was written, along with the title of the RFC. One thing I wanted to point out that I found while I was doing my research for this was that certain RFCs have errata. Whenever an RFC is written and published, that document stays the same forever. It never changes. If there are changes that have to be made to that, they're added to the errata section. It's very important that whenever you're looking at an RFC, and generally you're only going to see this if you're looking at it in the HTML version. The PDF and the text versions won't show you on the RFC itself whether or not any changes have been made. But once you'll click on the errata section, and it also mentions that they're below the standard that errata does exist, it'll take you to the page of changes that have been made or updates that have been made to the RFC that didn't necessarily warrant a new RFC, but are nonetheless important to know about if you're researching that RFC for whatever purposes. It'll also tell you if it was obsoleted by or updated by any other RFCs. And then, so what? So why do we care about RFCs? And just out of the blue, I'm just going to throw in a couple memes from my cat, just because I think they're funny, and just to kind of re-engage you with this very riveting subject. So, security use cases for RFCs. RFCs tell you what's expected of a particular protocol, for example. If you read down into the depths of that RFC and you learn everything you can about that protocol, you know that that protocol is supposed to operate like that in the wild. Well, if you're an adversary and you know how the protocol is supposed to operate, you might be able to come up with some ways that the protocol is not expected to operate and get around someone's defenses using those techniques. So as a blue teamer, you can use the RFCs to understand more fully the protocols and the information flow, networking of your systems, so that you can fully understand where some of the weaknesses might lie within those protocols. Every RFC has a security consideration section, which will tell you what the writers of the RFC think are possible security considerations. Those are great to look at. For example, TLS 1.3 just came out as a new RFC, as a new standard. If you go into it, you can see the differences are highlighted between 1.3 and 1.2. And a number of new features are introduced, but also a number of potential vulnerabilities that those new features could possibly create are explained in the security consideration section of that RFC. Red teamers, you can use it the same way as an adversary would in terms of developing exploits. You dig down into a protocol deeper than anybody really ever goes because they don't read the RFCs. And you can find those small little areas where no one's paying attention. Hardware, software, security tools haven't thought about that particular feature of that protocol. You can use that to create an exploit to bypass someone's perimeter. And so as much fun as that was, we're going to have even more fun with RFCs because they're not completely as dry and boring as they look like they might be. So in actual RFC 2119, a lot of you have probably seen this, keywords for use in RFCs to indicate requirement levels. Whenever you see must, must not, required, shall not, should not, recommended, may, optional, in a document, this RFC explains how you are to interpret that. It's kind of funny, they had to put out an update RFC, I don't have the number off the top of my head, that actually specifies that the words have to be capitalized in order for them to mean what they mean in RFC 2119. Well, then RFC 6919 came out, which is further keywords for use in RFCs to indicate requirement levels. The keywords must, but we know you won't, should consider, really should not, ought to, would probably, may wish to, could, possible, and might. They're all explained in this document as to how they should be used. Now, the header for this document, you'll notice the date of all the RFCs that are listed in the RFC register. The only ones that'll actually have a day are the April Fool's RFCs. And those will be 1 April of whatever year those were accepted. There are 5 non-April Fool's RFCs and currently 61 April Fool's RFCs that have been published as official RFCs. Probably one of the most famous non-April Fool's RFCs is ARPAWalkie that came out in 1973. This was a remake of Lewis Carroll's nonsense poem, Jabberwocky, but with a little bit of network engineer humor added to it. I'd recommend looking that up and taking a run through that because that's a fun one. Another notable April Fool RFC that caught my eye was the address is the message. RFC 1776, it came out in 1995. And basically it says that it's not what you know, but who you know. Choosing an addressing scheme that makes it possible to talk to everyone while dispensing with the irrelevant overhead of actually having to say anything was very important. So the address is actually the message whereby you don't have to say anything. You just address it and send it out. You got RFC 1925, the 12 networking truths. Number one, it has to work. Number two, no matter how hard you push, no matter what the priority, you can't increase the speed of light. And the corollary to that is no matter how hard you try, you can't make a baby in much less than 9 months. Trying to speed this up might make it slower, but it won't make it happen any quicker. Third networking truth is with sufficient thrust, pigs fly just fine, but it's not necessarily a great idea. Fourth networking truth is that some things in life can never be fully appreciated nor understood unless experienced firsthand. Some things in networking can never be fully understood by someone who neither builds commercial networking equipment nor runs an operational network. Number five, it's always possible to agglutinate multiple separate problems into a single complex interdependent solution. In most cases, this is a bad idea. Number six, if it's easier to move the problem around, for example, by moving the problem to a different part of the overall network architecture, then it is to solve it. And the corollary to that is it's always possible to add another level of indirection. Number seven is it's always something. Corollary to that is good, fast, or cheap. Pick any two. Number eight, it's more complicated than you think. That's definitely networking truth. Number nine, for all resources, whatever it is, you need more. And the corollary to that is that every networking problem always takes longer to solve than it seems like it should. Number 10, one size never fits all. Number 11, every old idea will be proposed again with a different name and a different presentation, regardless of whether it works. And the corollary to that is number 6, it's always possible to add another level of indirection. And the last networking truth is in protocol design, perfection has been reached, not when there is nothing left to add, but when there is nothing left to take away. And if it bothers you that I'm reading directly from the slides, I apologize, but I'm taking these directly out of the RFCs, and there's really no other way to pass that along. So I hope you're still enjoying it. RFC 2795 is the Infinite Monkey Protocol Suite, or IMPS. This is based off of the theory that if you take an infinite number of monkeys, put them in typewriters, then eventually one of them will produce the entire works of William Shakespeare or a good television show. So the suite contains communications and control protocols for the monkeys and for the organizations that work with them. There's 4 primary entities that communicate with the IMPS network. You've got the zoos, which are the groups of monkeys, which is where they're located. You've got the simian module, which is physically attached to the monkey, which provides communications between the monkey and zoo. The simian uses the chimp protocol to communicate with the zoo. And the zoo uses the keeper protocol to interact with the simian. So whenever the zookeeper sends a request, the simian must send a keeper a response. So right now we're talking about that part of the protocol. So whenever the keeper sends a code out to the monkeys, for example, to check and see if the monkey has a heartbeat, to wake up the monkey, to make sure the monkey's typing, stop all monkey business, then the monkey has to respond. And some of the responses is that the monkey can say he's asleep, he's not at the typewriter, he could say he's dead. The monkey can refuse the request. If that happens, then chances are this will probably happen. Another April Fool's RFC is the etymology of foo, RFC 3092. Most of us have probably heard of foo or foobar. Up to 2001, approximately 7% of the RFCs that had been written contained the terms foo bar or foobar. Well, for non-English speakers, this might create a problem. So somebody wrote this April Fool's RFC to rectify that deficiency by explaining the entire etymology of foo. That's definitely a good read and highly recommended. Another good one is the security flag in the IPv4 header, otherwise known as the evil bit. So this contributor suggests that you can define a security flag in a IPv4 header as either being malicious or non-malicious. Benign packets will set their bits to 0. Those that are used for attacks will set it to 1. That way, that just makes it a little easier for defenders to know what's inbound. Someone also thought it would be nice to have the TCP packets denote their mood. They obviously can't feel. However, a packet could get upset, if it's retransmitted, if there's no accuracy for it, it might get angry or frustrated. And if that's the case, it can change some flags in its header to denote its mood. And the flags break down to ASCII characters, emojis to illustrate how the packet's feeling at the time. The next one is one of my favorite, RFC 6592. This goes into great detail on the null packet. That's one of my favorites. Highly worth looking into. Next one is RFC 7511, which proposes scenic routing for IPv6. So this is looking at IPv6 and it's saying it might need a little bit more fresh air. And so it recommends routing IPv6 packets by implementing scenic routing so that you can either utilize avian IP carriers, wireless technologies, whatever it is to get those packets out of the fiber, out of the ground, and into the air and sunlight. And then you have 8135, which is complex addressing in IPv6. Someone didn't think that the addressing scheme for IPv6 was complex enough. So they came up with a number of new options for addressing IPv6 packets. You've got natural addresses, complex addresses. Some are imaginary. Supported addressing schemes are safe addresses, virtual rational addresses. There's even transcendent addresses. And then you have the geometric addresses, which are my favorite, which are round, square, or polar shapes. And then finally, on some notable April Fool's RFCs is the Hypertext Jeopardy Protocol. So Hypertext Jeopardy Protocol, HTJP, it inverts the request response semantics of the HTTP protocol. So whereas regular HTTP would connect to a server, ask a question, and expect a response, Hypertext Jeopardy Protocol sends an answer to the server and expects the correct question. And this document explains how all that works. So as we're going along and minding our own business, all of a sudden, zombies or asteroids or nuclear weapons, whatever it is, something's going to happen that's going to cause an apocalypse. And when that happens, all of your electronics, everything, society, everything's done. And what's the most important thing that you need to do when that happens? My monkey's letting me know. And secondly, that's some good advice. So surviving the apocalypse using April Fool's RFCs. So As we went through those April Fool's RFCs, you probably never thought that there were some of them that we've yet to cover that might actually save your life once the apocalypse continues, I guess we could say, or actually really comes. One of the most famous April Fool's RFCs that most of you have probably heard of is RFC 1149, standard for the transmission of IP datagrams on avian carriers, otherwise known as IP over carrier pigeon. Well, that RFC was followed up by 2549, which is IP over avian carriers with quality of service added, and that was followed up by 6214, which adapts 1149 for IPv6. Well, there was a group in 2001 in Norway, the Bergen Linux user group, that actually did a proof of concept for RFC 1149. They took a test packet, which you see here on the screen. This is one of the participants with the avian carrier. They've attached the test packet to the avian carrier. The avian carrier, the ping packet that's attached to its leg is currently timing out. But eventually, it moved on. It's heading towards those mountains over there where the endpoint is with these two gentlemen that they're trying to ping. Once they received a packet, they would then return the response. And you can see here, this is one of the packets being returned to the originator and the returned packet. And this is the group that conducted that experiment back in 2001. And this was their final write-up on it, if you will. They showed that there were 9 packets transmitted, 4 packets received with a 55% packet loss. Of those 5 packets that they didn't receive, three of the avian carriers didn't return during the testing period. 2 of them that did return, somebody forgot to shut the cage door at the receiving end, and so they couldn't attach the packet for them to return with. They did note the time that it took for these simulated pings to take place, and each packet averaged 87 minutes for a ping. Nonetheless, this group declared this a success in their final report, and they were waiting for other implementations so that they could try to do some interoperability with this RFC. Well, the value of this, now that we know that this proof of concept works, is that when the apocalypse comes, but you want to continue your computer communications, there's one way to do it. There's also another way to do it that you need to have a little bit more line of sight, but it's the transmission of IP datagrams over the semaphore flag signaling system. So the semaphore flag signal and the IP over semaphore flag signaling system uses the traditional semaphore code, which you can see there below, to either transmit letters A through Z, or if you're using it in IP over semaphore flag signal system protocol, you can transmit hex on the left, and on the right, you can transmit control signals. This one might be a little more difficult just because of its line of sight requirements, but nonetheless, you can still continue your computer communications. The last issue to discuss for the apocalypse as it relates to RFCs is the April Fool's 2550 RFC, the Y10K and beyond problem. So it talks about the Y2K problem that we had, explains the fact why we had that problem, because of the 2 digits that represented the date. So once they fixed it, they thought everything was good to go, but no. These folks realized that this is only going to be good until the year 9,999, at which case they're going to have to switch to 5 digits. And so this isn't something that necessarily needs to be fixed today, but if the apocalypse keeps us out for many, many, many centuries, this is something that's going to have to be considered. And just for fun, decided to throw in one more meme there. So in conclusion, RFCs contain a vast amount of information. In all honesty, it is a very dry subject. But once you start exploring RFCs, once you start exploring the website that contains them, and you see how they interact with each other, and you just see the depth of knowledge that can be found in them, you may want to continue doing it even more. What's especially interesting are the very early RFCs. The very early RFCs were more of communications, letters and notes, emails between the founders of the internet and what their thoughts were on what they were creating, the problems that they were seeing and how they were going about fixing them. So it just makes for very interesting reading to see where the internet came from and what the folks who created it were thinking at the time. Secondly, RFCs are your friend, and they do love you very much. And again, rfc-editor.org is where you can find everything you need for RFCs. Also, tools.ietf.org has a lot of great information on the process whereby the internet standards are created. I did want to plug a book, Where Wizards Stay Up Late, The Origins of the Internet. This is a fantastic read, and you are right there as the internet is being developed. It's very interesting for those of you who are interested in the history of the internet. And just a few public service announcements, and then I'm finished. Always remember, safety third. Stickerum on Twitter has all your safety third needs. Go check her out. And then friends don't let friends drink, ever. Malort. So some of you out there who do let friends drink Malort, you're wrong. So don't do it again. And then I can't say thank you without a meme. So here's my meme saying thank you. And I would just like to thank you for attending. This has been great. The staff at Circle City has been so wonderful. The way they pulled this off was just awesome. And I'm very honored to have been given this opportunity. So thank you very much.